And so the first one says the degrees of unsaturation. So you're going to look at the formula in the upper left-hand corner, and you've got C4H8, which has C4H8O2. So when you do your degrees of unsaturation, remember you're going to do CnH2n plus 2, and you're going to ignore the oxygens. So you're going to have CnH2n plus 2 for this one would be C4H10, and then you'll subtract out the H8, gives you 2, divide that by 2, and you will get 1 degree of unsaturation. And so put 1 in that box and then hit submit. And so the next thing you're going to do is you're going to put A, B, and C underneath each of the signals in there. And it will transpose the A up above. And then you're going to estimate the chemical shift. So that's about 4.1. That one's about 2.1. And that last one is about maybe 1.3. So fill in the boxes and then hit submit, and it actually will correct you if you're off by a little bit. So now we're going to do the integration, and so we're going to integrate this whole area right here. This is called the integration, and so since we know that there's 8 hydrogens, we're going to tally up the sum of the inches high each of these blue stepping brackets equals. So you're going to use a ruler. So when you use a ruler, this first one is 1.5 inches. This second one is 2 inches. And the third one is 2 inches. So when you tally that up, you're going to get 5.5 inches. So we have 5.5 inches distributed over those 3 peaks. So now we're going to divide, since we know there's 8 hydrogens divvied up over all 3 of those, we're going to take 8 hydrogens and we're going to divide by 5.5 inches. And that gives us 1.45 hydrogens per inch. And so then I'm going to go back and calculate how many hydrogens this is. So since this first one was 1.45 inches, you're going to, 1.5 inches, you're going to multiply it times 1.45 hydrogens per inch, and that will give you 2 hydrogens for the first one. And the second one is 2 inches times 1.45 hydrogens per inch, gives you 3, and so does the last one. So we can see that we're pretty much correct because we've got 8 hydrogens, and the first one is 2, an integration of 2. The second one was integrated to 3, and the last one was integrated to 3. So remember, integration means the number of hydrogens that are being represented by that cluster of peaks. So that means that first peak at 4.1 is going to represent a structure that is 2 hydrogens. So when we go to do multiplicity, we're given a few words to describe how many peaks are in that cluster. So this one has 4 peaks in there, so we call it a quartet. B is just singlet. It just has 1 peak in it. And C is a triplet. There's 3 peaks in there. So the next question is, the adjacent hydrogens means how many nearest neighbors do you have? And the peak that we see is yourself plus your nearest neighbors. So basically, you're going to take your quartet for the first one, subtract 1, and that's the number of adjacent hydrogens you have, how many nearest neighbors you have. So a quartet will have 1 for themselves and 3 nearest neighbors. A singlet will have no nearest neighbors because a singlet only represents itself. And then a triplet will have 2 nearest neighbors. So this is the hard part. So you are given a whole list of possible hydrogens that could be. And so our little test tube guy over here is going to give us some clues. So let's see what he has to say. So it says, remember the hydrogen color of the selected fragment matches the signal label. So 3 hydrogen singlet at 2 ppm indicates a methyl group adjacent to a C double bond O or a carbon-carbon double bond. And then the oxygen shifts the 2 hydrogen quartet to 4 ppm. So this means that this A is going to be near an oxygen. Okay, let's see. All right, let's see if we can figure this out. So we need to incorporate 2 oxygens, and we need to have a C4H8O2. And so as I start to put in some ideas, the program will actually draw it up there. So it said the clue, unfortunately, our clue goes away once you click on it once. But you can go up here and use that little question mark up above, and it'll help you also. So I want something that has 3, itself is 2 hydrogens, because that's the integration, and has 3 nearest neighbors, and is shifted by an oxygen. So let's see what we have in here. We have a CH2. We have a CH2 next to an O. So there are 2 different kinds of CH2s next to an O. So it depends on which side you want to connect to the next bond. This one says it is 3 and has no nearest neighbors. So it says it could be a 3 connected to a C double bond O. That's one possibility. And then now I need a triplet